Well, the first thing we think about after we think about temperature is rainfall. There's a fairly basic relationship which says that warm air holds more water, so from that we'd expect that as the atmosphere warms with global warming, it would also have more rainfall. Now, this isn't true everywhere, there's some variation around the globe, but on a global average level, and in most places, particularly at high latitudes, so for example in Scotland, we expect more rainfall. Now, not only that, but we expect more intense rainfall, again related to the same physical relationship. So we might get our rainfall falling in more intense bursts, and obviously that has implications for flooding, for example. The next thing we'd think about is, again related to where a lot of our rainfall comes from, is storms. So not only might storms become more intense, but we might expect that there are fewer storms, but each of them is more intense. And in addition, although this is quite uncertain, we might expect that where the storms travel, so that's the storm tracks, changes, and that's related to warming happening at different rates in different parts of the Earth. But that's quite uncertain, so it's harder to definitely know where those changes will happen. After storm tracks, let's turn to the ocean. So it's quite well known that as the ocean warms, sea level rises. So water expands as it warms, and that leads the sea level to rise. And as well as that, as temperatures warm, more ice and snow melt. So that as well leads to ice and snow, the water from those flowing into the ocean and raising sea level. Now again, that will happen at different rates in different parts of the Earth, but that can have really significant impacts on communities that are close to sea level. Finally, if we take a step back from the effects of warming and just look at the direct effects of increasing carbon dioxide, there's something in the oceans called ocean acidification. So as carbon dioxide from the atmosphere is absorbed in the ocean, it leads to the ocean becoming more acidic. That means that there are severe implications for marine organisms, for example coral reefs and mollusks, which are less able to form and therefore are severely damaged as the ocean becomes more acidic. So the first thing to say about this is that although we expect rainfall globally to increase, there's quite a lot of uncertainty about understanding these effects. First of all, it's harder, so there's more variation between climate models about exactly where rainfall changes and by how much. And secondly, if you're going to find out anything about actual water resources, you have to put that through a hydrological model. So you have to know where the rivers are, what the lay of the land is, what the soils are, and what the land use is. So it instantly becomes a more complicated problem. That said, we know that globally rainfall will increase, and we know that particularly in high latitudes that will be the case, although in the subtropics in some places we expect rainfall to decrease. There's also this relationship that intense rainfall, the most intense rainfall on any day, will increase more than average rainfall. So that has implications, for example, for flooding, if you're getting all your rainfall in short, intense bursts. Going on from that, thinking about drought, we know that there are some regions that are going to become drier, and also if the rainfall is falling in more intense bursts and just running straight off the land, then we might have implications for drought in the longer term. On another note that's kind of more obvious, as temperature increases, we expect more precipitation to fall as rain and snow, and we expect glaciers and snowpack to melt more quickly. So we've already seen that globally, in regions where the rivers are mostly fed by snowmelt in the spring, that snowmelt becomes earlier, and so you change your seasonal pattern of when the rivers are at their peak flow. And that's already having severe implications for communities which rely on glacial melt. On a slightly different question, there's also going to be implications for the actual quality of fresh water. So, for example, if you have very intense rainfall, that can flood pollutants into a river. And also as the water gets warmer, those pollutants might have more of an effect. So there's lots of very complex issues around actual freshwater availability and also how useful it is. At a global level, there are two main processes that lead to sea level rise. So the first one is called thermal expansion. So that's referring to the fact that as temperatures increase, so that's the thermal bit, the volume occupied by a given mass of water becomes larger, so that's the expansion bit. So the same amount of water will occupy more space, leading the ocean to rise, the sea level to rise. The second cause of sea level rise is that at the moment a lot of water is stored permanently or semi-permanently on land, in glaciers or in snowpack. Now, as the climate warms, that snow and ice melts, and that leads to more ice that's currently stored on land becoming stored in the ocean as liquid water, and that obviously leads sea level to rise. Now, as we look back through the 20th century, we can see that sea level has already risen globally by about 20 centimetres over the course of the century. And as we look forward, the Intergovernmental Panel on Climate Change is that it will be about 40 to 80 centimetres more sea level rise, average globally, over the next century. And that's in a business as usual scenario. It's about 20 centimetres less if we mitigate against climate change, so if we take action to reduce our emissions. But that doesn't take into account the possibility that a lot of the Antarctic ice sheet that we'd expect to melt might melt. There's still some uncertainty in our physical understanding. And if some of that Antarctic ice sheet does melt, it could contribute another several tenths of a metre sea level rise by the end of the century. So again, that's not the same everywhere. There will be regional variations in that sea level rise, but that's the average of kind of up to a metre by the end of the century.